Okay, so here we go. We have, now that you have your Hebden book, and if you have not, is there anyone who's not signed out one of these? Yeah. No, you don't need it here. I will always have a class set. Like if we use it in class, there will always be enough here for you to just use in the classroom, okay? But if you are going home and reviewing this, the pages are here, right? Also, if you're going home and you're reviewing it and you didn't quite understand what I was talking about, Tyler has a video on this as well. We're not going to watch Tyler today, but you can hang out with Tyler to help with that. Just like with the single conversions, you are going to write down your unknown. So you're going to look for the question word. You're going to look for your initial quantity. Now, the initial quantity is always connected to the unknown in the sentence. So you're going to look for connecting words that says, how many inches is 10 feet? See how the 10 feet is connected to the how many inches? So those two things are connected together. You're going to write down as many conversion factors as are given in the problem, so you'll write down those. You're going to map out the problem. Most people say, do I have to map? And my answer is no, you do not have to map, but it can be very helpful. So map if you're finding it helpful. You don't have to map if you're getting it correct every time without doing the map, okay? You might need to find some other well-known conversion factors. You know, there's 100 centimeters in a meter, things like that. There's 60 seconds in a minute. And if you recall from last day, we wrote down our unknown, and then we had our initial times our conversion factor. Well, all we do now is to do multiple conversion factors. We just add them on. We just multiply by one and then multiply by a second one. If we need to do a third one or a fourth one, we can just put them all in one sentence, essentially, one mathematical sentence, okay? You will fill in the value for I, and then remember you're going to write times and then a line. Yes? You're going to fill in the units. You're going to have unit B and unit A. I like filling in the units before I put the numbers in because it makes sure that I put the numbers in the right place. Okay? You'll have a number up here of unit B and a number down here of unit A. You'll show your unit cancellation. Ooh, the SIF figs. That should be a G, obviously. SIF figs. Check that your remaining units are correct. Okay, so you're going to show your unit cancellation. That way you'll know, did everything cancel out the way it should? And finally, you are going to box your final answer. Okay. So, how many seconds are in one day? Have I written down everything there for you? Yes, I have, but that's okay. I'm going to kind of just do it over here. How many seconds, so my unknown is the number of seconds, are in one day. That's connected to that. So my initial quantity is 1 day. And I don't know about my conversion factors yet. I know I want to start with days, and I want to finish eventually over here with seconds. What could I convert days into that would get me closer to seconds? Hours. So I'm going to say, okay, I'm going to go from days to hours. What could I do with hours to get closer to seconds? I could convert that to minutes, and then of course from minutes I can go to seconds. How many steps will I have? How many different conversions? 3. I'm going to have 1, 2, 3. So when I'm actually doing my calculation, I'm going to have 1, 2, 3 conversion factors like that. Yeah, so that's what it's eventually going to look like. All right. So we can say, I want to find the number of seconds. And we are starting with 1 day. Step number 1, I want to convert between days and hours. Where are the days going to go on that line? Days are going to go at the bottom, so they cancel out. And then hours are going to go on the top. I'm not even going to write in my units yet. I'm going to leave that for a minute. Days are gone. I now want to go from hours to minutes. So what do I need to cancel? Hours. So hours have to go on the bottom and minutes have to go on the top. That means my hours are going to cancel and I'll be left with minutes. And finally, we're going to go from minutes to seconds. So minutes have to go on the bottom so they cancel out, and I want to have seconds. Oh, look, isn't that nice? I'm going to end up with seconds, right? And now I can go through and I can put in all of my numbers. There are 24 hours in 1 day. There are 60 minutes in 1 hour, and there are 60 seconds in 1 minute. And we get, what did it do to my calculator? I probably have it written down here. Let's see. Do I? Yes, I do. Okay. 24 times 60 is equal to 8,600. Now, this is not the best example when it comes to significant figures because, you know, we always get caught up in, is that day an exact quantity? So does it have infinite sig figs, or does it have 1 sig fig because it's just 1 day? I would tend to argue that we're asking about an exact day, but I wouldn't give you a question like this on a test because it could be ambiguous. Yes, so we're just going to leave it and ignore sig figs for right this moment, okay? It's just a nice question because it gives us numbers that we know a lot about. Okay? You could do this in a series of steps. You don't have to do it all on one line, right? You could say, I could convert my my days into hours and put an equal sign, and then I could convert separately on the next line. I could convert my hours into minutes, and then I could convert my minutes into seconds. So it is okay if you want to do them on 3 separate lines, or you can write it all on 1 line. It's your choice. Doesn't really matter. Okay, so that's all we've got there. Oh, and box your final answer. There we go. Why bother with steps 7 and 8? Why not just write the conversion factors, the numbers, and all right away? What are steps 7 and 8? I don't even know. Oh, step 7. Oh, just writing down like this business where you just write times, times, times. And 8 is just drawing your map. Why bother with it? Students who do this, at least to start with, tend to make less mistakes than people who don't. Okay? Because sometimes if people don't do step 7, where you just write out times line, times line, times line, you know, they won't put in the right number of conversions, and I don't know. Anyway. Do you have to box your final answer? Yes, or highlight it, or put stars on either side of it. It's just good practice. It will make anyone reading your work, like me, happier. Okay? You want a happy teacher marking your work. Can I leave out any other steps when you are very experienced and very confident? Yes. Okay, but this all looks like so much work. It's not. When I wrote it, it's, I don't know. I'm babbling now. Real life problem. Like this actually occurred many years ago now, probably about 15 years ago. I needed to drive some debaters to a tournament in Penticton. Do we still have a debate club at this school? I don't know. Anyway, we used to. I used to run it, but anyway. I needed to drive some debaters to a tournament in Penticton, and I needed to include the cost of fuel in the cost of the field trip. So I looked up the distance to Penticton and found that the driving distance was 403 kilometers. One of the things that might be nice is for you to invest in a highlighter so you can highlight your numbers, because often these problems have a lot of words. Yes? It's nice to just be able to say, oh, look, there's a number, 403 kilometers. I look up the highway mileage for my 2002 Honda Odyssey. Do you think that 2002 is important in terms of the numbers we're calculating with? No. Obviously, it was a while ago. I don't own that vehicle anymore. And I found that the highway mileage was 25 miles per gallon. I buy my gas in liters, though, so I have to convert from gallons to liters, and I looked this up, this conversion factor up. 1 liter is 0.26 gallons. And finally, I know my distance in kilometers, not miles, so I need a conversion between kilometers and miles. 1 kilometer is 0.62137 miles. And you can see how long ago this was. The price of gas was $1.30 per liter. Okay. How much will it cost to make the trip to Penticton? So, how much will it cost? That's going to be our unknown. The thing that is connected to that is the trip to Penticton. So that's going to be our initial quantity. And what do we know about our trip to Penticton? It is 403 kilometers. So we're going to be starting with 403 kilometers and converting until we get to dollars. Okay? So if I was to take a look at this, I'm just going to shove that over there. All of this is written down below, obviously. I'm going to be starting with kilometers. What can I convert kilometers into, just given what I've got in the problem? Miles, because those two are connected, right? I have a conversion between those. So I can convert from kilometers to miles. I'm going to just call that MI. Miles can go to gallons, right there. Yeah, and gallons can go to liters. And then you go to the price. Right? So now, once you've sort of made that little chain, you can say I'm going to have 1, 2, 3, 4 steps. So I'm going to start with my 403 kilometers, and I'm going to have 1, 2, 3, 4 lines. Yeah? Step number 1, going from kilometers to miles. Where should kilometers go? On the bottom. And miles will go on the top. Next one, we're going from miles to gallons. So miles go on the bottom and gallons go on the top. Gallons to liters, so gallons cancel out by going on the bottom and liters go on the top. And finally, we cancel out liters and find our dollars, and I'll put them over here because normally we write the dollar sign first. And then you just go back into your question and you find all those numbers. right? We had miles per kilometer, 0.62137 miles, 0.62137 miles per kilometer. 25 miles per gallon, so 25 goes with the miles, 1 gallon. Gallons per liter, for every 1 liter there are 0.26 gallons, and the price was $1.30 per 1 liter. So we have 403 times 0.62137 divided by 25 divided by 0.26 times 1.3 equals, and we get, calculator spits this out, 50.08244, no, just 2422. There we go. You do not need to write that entire number down. I'm just showing you what the calculator spat out, yes? Let's go back to our question, because we should consider significant figures. This is not like that other one where it's sort of ambiguous. 403. How many sig figs there? 3 sig figs. How many sig figs in 0.2137? 5 sig figs. How many in the 1 kilometer? Infinite sig figs. How about 1 gallon and 25 miles? 25 miles per gallon. Let's go with the 25 first. Is that an exact number, or is that something somebody had to measure? It's the mileage of my car. It's how many miles I get per gallon. Is that an exact number? No. Okay, so this one is not exact, so that's 2 sig figs. Okay, it could be 26 miles per gallon or 24 miles per gallon. How about the per gallon? How about the per 1 gallon? That one is infinite, okay? Whenever you have like per 1 thing, that 1 is always going to be infinite, okay? And 0.26 gallons per liter. Are gallons and liters in the same measuring system? No, one of them is imperial and one of them is metric. So the 1 is going to be infinite, but the 0.26 is going to have 2 sig figs. And then finally we have 3 sig figs here. So we do our thing and we say 2 sig figs is the smallest. So that was going to equal $50. Can I leave it like that? No, I would either have to put a dot there, or I would have to say, and this would be really weird to write a price like this, 5.0 times 10 to the 1 dollars. Okay, that's really weird. Obviously, if I was doing this, I don't need significant figures, to charge them, that price. But it's just a fun sort of example where real life was used. Okay. Now, do we have any other examples, or are we just, oh, there's some exercises. Good. Do you guys want to do some exercises, practice those? Yes? Okay. Give those a go. I'm not sure what it would sound like now. I haven't played in 20 years. Yep.